Hi, we are starting chapter 18.5, Free Energy and Entropy today. Do you know fires can start on their own? That's spontaneous combustion. It really does happen. Something happens that gets the right condition so that a building, a fire, a grass, or something can start on fire. It must have something to do with energy, I think. So what are two characteristics that must occur for spontaneous reaction? So if we're going to look at spontaneous reactions, we're going to want to look at something called free energy. So what we do is if we have a chemical reaction that occurs, we take some of the energy that might be released and we use that to do work. Okay, for instance, in our car, we have gasoline. Explodes. It really does explode in your car. But fortunately, it's only a little bit. So when your spark plug ignites this gasoline, there's a rapid explosion and it pushes a piston, and that changes that chemical energy, heat energy, into mechanical energy, and the pistons then drive your motor, which drives your wheels. And that's how it works. Now there's spontaneous reactions versus non-spontaneous reactions. Spontaneous means it happens on its own. Okay? For instance, the equation shown here, carbon dioxide making carbon and oxygen, the decomposition, is not spontaneous. You don't hear CO2, you don't see CO2 turning into black soot and some oxygen. Okay? It's usually the other way around. Okay? Carbon and oxygen will combine to make carbon dioxide, not the reverse. Now, if we think of a nice balanced chemical equation, we will have two groups. One groups that are examples of equations that will actually occur, and the other ones are the ones that do not tend to occur. What chemists will do is when they're thinking of making a new compound a lot of times, they will look at the energy that's required to make that compound. Is it something that will start being made almost immediately with a little bit of activation energy? Or does it require significant more energy to make that product? Is it more stable in the reactant state than it is in the product state? So these are things that chemists look at all the time. So a definition of a spontaneous reaction: it occurs naturally and tends to favor the formation of products, and the conditions at which they occur, this reaction occurs, must be stated. You must know what the conditions are, because if the conditions change, well then you might have a situation that's spontaneous. For instance, if you're at 35, let's say minus 35 degrees C, will ice melt spontaneously? No. But if you're at 20 degrees C, ice will melt spontaneously. So my condition has changed from a very, very cold temperature to room temperature. Now a spontaneous reaction will produce a large amount of products and release free energy. For instance, fireworks are a result of highly favored spontaneous reactions. So they basically explode, electrons get excited, and then they fall back down, and that's why you see the colors you see. One that does not favor formation of products at the stated condition is called non-spontaneous. So there's a little bit of product produced. Now, usually in reversible reactions, one side is usually favored over the other side. So one side is more spontaneous than the opposite side. This should really say less than. Less than 1% of carbonic acid making CO2 and water. So most of your product is going to be CO2 and water. So it's spontaneous that way. The forward reaction is spontaneous and releases free energy. So that's the preferred reaction, even though you will have it going back to make some carbonic acid. So this way, oops. This way is non-spontaneous. Okay, and this way is spontaneous. And remember, this is less than 1%. All right. Now, here's another reversible reaction. This one's a little bit different. Okay, so we have two aqueous solutions and we're making a precipitate. Here's our precipitate. And then we have aqueous. There is a little bit of equilibrium going on there, but this is going to be the preferred direction because it's going to be harder to get that solid to react because it's going to be sitting at the bottom of the beaker. Okay, so the reverse reaction is going to be non-spontaneous. So again, this is favored. There's going to be a lot more cadmium sulfide in the beaker than either of these two aqueous solutions, the reactants. Okay, now spontaneous and non-spontaneous have nothing to do with the reaction rate. Okay, they basically, you could have something that takes a year, even though it is spontaneous, it just takes a long time for the reaction to occur. Now, as I said, spontaneity is based on conditions, and I mentioned the ice cube. Okay, so the conditions will affect. So things like temperature, pressure, all those sort of things can affect if the reaction will be spontaneous or not. Nope, I didn't want to do that yet. I guess I did. Okay, so for instance, photosynthesis. Photosynthesis is a complex set of reactions that convert carbon dioxide and water to sugar and oxygen. This does not occur normally. All right, there are parts of this photosynthetic pathway that require sunlight, which is energy, plant pigments like chlorophyll. They all play their roles so that this reaction produces the sugar. Without them, this reaction would not be spontaneous. So they're kind of like helper reactions. We call this a coupled reaction. So maybe the other reactions are favored to be spontaneous and they carry along the carbon dioxide and water with them. So one reaction releases energy, and that energy is then used by the one that may not normally occur to make it occur. And this is very, very common in biological systems. Okay, so these complex process of coupled reactions are very, very important in animals and plants. Okay, this is going to be an educating question that I want you to think about. Decomposition reactions that occur inside a pile of oily rags or a damp stack of hay cause heat to build up. If the heat cannot escape, the temperature within the pile or stack will rise. How can a rise in temperature cause a fire to start on its own? This is going to be something that you have to answer based on what we've just discussed. So think about it. You might want to take a quick screenshot of the question. Or I'll rewrite it for you. You don't have to do that. And I'll be back in a second. Okay, I hope you did good. Let's see what the answer is. Okay, the combustion reaction is a non-spontaneous reaction that can be made to occur when it is coupled, okay, to a spontaneous reaction. The decomposition reaction releases energy that is used by the combustion. So what happens is, as those the other rags and the stack of hay decompose, you're going to build up heat, and that heat eventually is going to start a fire. Okay, here you go. Here's another educating question. Which of the following is always true of spontaneous reactions? Read through that. I'll be back in a second. Hope you chose letter B. They release free energy in favor of the formation of products at the stated conditions. That's always true. Okay, A, we kind of talked of some cases where that could be true, and we also talked about coupled reactions, but this letter B is true for everything when we think of spontaneous reactions.